Good evening. I'm Jeanette Miller. I'm the Associate Director of the Delaware Environmental Institute, and it's really my great pleasure to welcome you to this evening's DENIN Dialogue. Tonight's special guest has been compared to a cross between Woody Allen and Carl Sagan for his very enthusiastic efforts to communicate the excitement and importance of science to everyone. He's traveled the globe from Antarctica to Greenland in pursuit of his clues to the Earth's past climate history, particularly clues locked deep within the great polar ice sheets of our planet. He's mostly well known for his work on ice cores and discoveries leading to the conclusion that dramatic shifts in global climate have sometimes occurred within relatively short time periods, measured in decades and centuries rather than millennia. Richard Allen is the Evan Pugh Professor of Geosciences and an associate of the Earth and Environmental Systems Institute at the Pennsylvania State University. With over 225 publications, he has been asked to provide advice to the highest levels of the U.S. government and has been honored with numerous awards for teaching, research, and service, including election to the U.S. National Academy of Sciences. He has chaired the National Research Council's panel on abrupt climate change, and he's participated in the IPCC, the Intergovernmental Panel on Climate Change. Dr. Alley's popular account of ice cores and climate change, titled The 2-Mile Time Machine, was Phi Beta Kappa's Science Book of the Year in 2001. He's also author of Earth, the Operator's Manual, the companion book to the recent PBS miniseries of the same name, which he also hosted. Dr. Alley will be interviewed tonight by Adam Rome. Dr. Rome is an environmental historian of the United States and a journalist who is a member of both the History and English departments here at UD and co-director of the College of Arts and Sciences Environmental Humanities Initiative. He came to Delaware earlier this year from Penn State, where he had the opportunity to get to know Richard Alley personally. Dr. Rome's first book, The Bulldozer in the Countryside, Suburban Sprawl and the Rise of American Environmentalism, won the Organization of American Historians Frederick Jackson Turner Award. His history of the first Earth Day in 1970 will be forthcoming soon from Hill and Wang. Please join me now in welcoming Richard Alley and Adam Rome.
Welcome to UD. This is your second visit, you told us at dinner, so we hope this will be a fun and enlightening discussion, and can't wait to hear what everyone says from the audience. We'll be taking questions in 40 or 45 minutes. But I thought I'd start. I'm just wondering how you came to be interested in science. Were you a Johnny Quest fan when you were a kid, or did it come later?
Yeah, I collected rocks, and I was a gardener. And there's a lot to be said for raising a garden, and a lot to be said for crawling around in caves. And then I fell in with evil company that liked to go out to national parks and climb mountains and things like that. And then what do? You know? And I almost went into journalism. And at the time I came out of high school, the guidance counselor said, you know something? There's no jobs for journalists. What kind of? But they said geologists could get a job. You could go do oil. So I became a geologist.
And you did do oil, but very briefly, right?
One summer at Dallas, was working on a sedimentary basin and how the rocks accumulated and where the fossil fuel came from and how it migrated and when it got cooked. And it was a great place. At that time, the oil companies actually sort of had mini universities inside of them. And the people I worked with were brilliant, and they were hardworking, and they were learning things, and they played soccer at lunch. So, played soccer at lunch, yes. So you got some soccer players sitting over here in the front. So it was a great place, but we looked at each other. Cindy and I spent the summer in Dallas, and we were a mission to find the best nachos in the Dallas-Fort Worth metro area. And at the end of that, we said, no, we want to work with people. We want to go back to school.
And when you started, the field that you really are now renowned for was either not existent or was just beginning to be formed? I mean, you didn't start out studying glaciers, right?
Oh, heavens no. But I was looking for a summer job, and there were 2 of them open when I was an undergrad, and one of them was cleaning fossils with a dental pick, and the other one was actually trying to find the fallout of the atomic bomb testing in the ice sheet in Antarctica. And I sort of failed on that, but somebody else figured it out. And it's one of these things, we eventually ended up counting annual layers. And I say that's summer, that's winter, that's summer, that's winter. And someone says, how do you know you're right? And I say, well, if I count down this far, we know that in 1954 we blew up an island with a really dirty bomb, and in 1955 the stuff fell out all over the world. And you go down and say, this should be 1955, and look, it's hot. And then you go to the historical volcanoes and things like that, and all of a sudden you say, hey, this works.
And your professors humored you.
Indeed. In fact, they took me to Antarctica when I was a sophomore, so yes.
My God, wow. Well, I know that's going to be something people will be curious about. Your job is an adventure, or you've managed to make it into an adventure. Tell us about working under extreme conditions in order to learn the history that the ice cores reveal.
Yeah. So we, I did 9 seasons in Greenland, 3 in Antarctica, and a few in Alaska. The later ones were a little softer, but early on, you go to Greenland, and it's minus 20, and it doesn't get up to freezing in midsummer on the hottest day, or it used to not. And we started living in tents. And the truth is now I'm sort of embarrassed by this, that now people who go bring out human waste, but at the time we didn't. And you sort of went out in the wind and squatted. And
you left a trace.
We left a trace, yes. We did. And it was not terribly pleasant leaving the trace.
And tell me about Earth system science. I mean, it seems like the most complicated possible thing you could try to understand, the whole Earth. And you didn't start out thinking that that would be what you would do. So how did your career evolve? What did you have to learn after graduate school in order to do the kinds of work that you do now?
Yeah, because it's, ultimately, and this is something that sometimes drives students a little crazy, is that in our field, usually, you grab a hold of one strand and you follow it to the rope. And so I'm a geologist, and I rock hammers and maps and petrographic microscopes and a whole bunch of things that I don't use a lot anymore. And then I got a minor in metallurgy. So I materials science and metallurgical engineering, and I was going to learn how snow turns to ice on the polar ice sheets. And it's the same basic physics that they use down the road to make toilet bowls. So you take powder and you squeeze it and heat it, and it densifies. And then from that we got to looking at the layers in summer and winter and summer and winter, and then we got counting them, and this is 10,000 years old, and then we got looking at wait a minute, the layer is that thick, and it's that thick, and it's that thick, and it's that thick, and then boom, it's half as thick. And 1,000 years, it's only half as thick. That's because it only snowed half as much, and that changed in 3 years. And then we said, holy crap. And then I learned a lot of climate. So it is certainly something that none of us really can learn in school what we're going to do in our career, because things are changing so fast. And fortunately, I had professors who helped me learn how to learn.
I mean, that sounds like something, if you were mentoring our audience here, how do you teach someone to learn how to learn?
Oh, boy, have fun. I mean, and a lot of it is. It's the point where you say, wow, look at this. This is something that nobody knew. And I'm sitting, and it matters, and people can use it. And at the point where you're having fun, you almost can't not learn. You know, you have to do it because you got to see where the thread leads. And then it's, I think, having either the wherewithal to go back and learn the hard stuff, or else sticking with the hard stuff initially and getting the math and physics in. I took 2 physics courses as an undergrad, and I hated physics. And and I don't want to cast aspersions on my alma mater, but at the time I was taking physics, the light bulb was burned out, the switch was broken, the battery was dead, and somebody had stolen the wire. And so I quit after the second one, and then when I got into grad school, I went back and took graduate level physics. And the professor was deeply amused because I asked questions that were not the standard questions.
Give us an example.
Well, he was working on Bose condensates, and at some point I said, so is there any example of this in the real world? You know, and everyone was sitting there working on the statistics of Bose condensates, and at that time there sort of wasn't. And now they use them for all kinds of things. They're truly wonderful. But I kept asking things that all the other physicists knew, or else they knew that they weren't supposed to ask that one. So.
And when you realized that the ice cores were an archive, I mean, did you know right away, or did you have to figure out over time why that might be valuable, of more than just academic interest?
Yeah. So I think we had known already. This is a long and wonderful story of how ice cores came to be, and these early researchers, right after World War II, working for the government to try to understand how to keep soldiers and sailors from freezing in cold weather. And then asking, so how does biology work in ice? And then finding out that, in fact, ice is a pretty good bottle. If you put a bug in a little pocket of gas in ice, not much comes out and not much goes in. And so the bug has to live with whatever it's respiring in the ice all winter. And then saying, hey, wait a minute, if it's a really good bottle, there's all this ice in Greenland that has old air in it. And so this idea that we can actually get a history of climate from going to ice cores came from biologists doing physics to find out how people live in cold places. And it wasn't that someone said, well, let's go measure this and then see if we can make a story. It was someone said, this must work. The answer must be there. And then it went through military work, and then eventually it got to us. But it was a lot of these pioneers doing very interesting things that showed us that this must be there.
And it seems like, I mean, you can correct me if I'm wrong, but your most famous discovery is this idea of the unbelievably abrupt climate change. You write in both your books, actually, about Greenland suddenly realizing there was one decade when the temperature went up 15 degrees. So I'm wondering, and I'll tell one story. So one of the ozone hole scientists, when Sherry Rowlands, first realized what he'd found, he went home, his wife said, you know, how to go today at work, and he said, the work is going well, but it looks like the end of the world. So when you realized that Greenland had this unbelievably, shockingly fast change, you know, what did you go home and say to your wife that day?
Right, so we really realized this in a snow cave in Greenland, and we couldn't call home. But we sort of looked at it. So this idea, you know, the people a long time ago had you go to a bog in Europe and you take a sediment core and you look at the pollen in it and you see stuff that lives there today in the mud and stuff that lives there in the day and stuff that lives there today and then stuff that lives on the tundra. And then back to today, and then back to tundra, and back to today, and back to tundra. And so there's this history, and it looked pretty fast. And people said, hey, we should get really good records of that. So eventually we got these cores in Greenland to get really good records. And we were expecting that the change would have been 100 years, or maybe 50 years. And when we found out, and we're standing there looking at it, and it was mostly in 1 to 3 years. And I think there's this glorious excitement. You know something new. And we're looking, he's, wow, look at this, isn't this great? And then, I don't know exactly what words we used, but they were probably along the lines of, holy crap. Because it really is, the fact that a lot of things ended up changing very rapidly was really a surprise, and it's not the kind of thing that makes you comfortable about pushing really hard on the climate.
So keep going that way. I mean, the more you thought about it, what other implications did you begin to see from that discovery?
Right. So what ended up, something that's important with ice cores, is that the ice core has in it a record of how much it snowed there in Greenland. It has a record in it of what the temperature change was there in Greenland. But it has in it a record of what is blown by the wind from the deserts of Asia as dust, from the ocean as sea salt, and other sorts of things. And it has a record in it of trapped gases, including methane and nitrous oxide, a lot of which are coming from the tropics. So in the ice core, at one place, you have a record of a good chunk of the world, and there's no uncertainty in the ages. They're all on the same record. And so by the time we got the ice home and analyzed in the methane labs, we knew that most of the world had changed together really, really fast. And that led to a long exploration of whether that particular mechanism, what caused those changes, was going to happen in our future. And we're cautiously optimistic that we'll miss that particular one, but we're not positive. But it also sort of brings out this whole idea of a world with switches as well as dials. Most of the time, most of the world behaves itself. A little more sun, it's a little warmer. A little more dust blocking the sun, it's a little colder. And you can sort of do it. It's a dial, like setting the thermostat, turn it up a little, and it gets a little bit warmer. But it's clear that the Earth does have switches. And a switch, if you push very, very lightly, nothing happens. And you push a little harder, and at some point, boom, it changes. And it's really hard to predict. Virtually none of us could actually look at the light switch and say exactly how hard am I going to have to push on that light switch to flip it. And so this makes it uncomfortable for us as scientists, because we like to give you an answer with well-known uncertainties, and switches are hard to give answers on. But it makes it really interesting to deal with.
And when did you begin to think that you might want to write more popularly, try to communicate more directly with an audience beyond your professional colleagues?
Yeah.
Was there a single moment, or did it gradually come to you that you had some kind of a sense of...
Sort of crept up on me along. I started teaching general education when I first got to Penn State. And there's a whole bunch of really outstanding introductory geology textbooks that cost a lot of money, and they have way, way more words than most of the students wanted to read. And so I started writing little mini texts that had the right number of words and actually highlighted the pieces. And the students sort of liked this. It saved them, I don't want to spend, in those days it was $50, now it's $100, but the students sort of liked this. And then you get into the habit of sitting there and writing this stuff, and I found that writing it helped me sort it out. So that if you really can, you have journalism background, you're in the English department, you should know this, students. If you can write it in a way that he will say it's a good one, you understand it. And if you can't write it in a way that he will say it's a good one, you probably don't really understand it. It may be. There's a few things in math that it's just math, but for things that by the time it gets down to my level of simplicity, I'd better be able to explain it to you, or it's not in my mind right.
I know when we chatted over lunch in State College once, you said you had professors who taught these gigantic surveys who were showmen, who were skilled explainers of complicated concepts. And so I can see how you call on that in your teaching. And I don't know whether those courses are still called Rocks for Jocks, but how much of that carries over to the public when you try to, and how much have you had to learn new techniques in order to begin to try to reach a non-captive audience?
Yeah. I think it carries over really well. We have to start from this fundamental basis in understanding. And I think that for our science now, for climate science now, the big questions, we can provide really good answers, and we can provide really good answers that are woven together out of so many strands of evidence that they're solid. There's really not too much question about a lot of it. And then it's, once you have that basis, you know you got it in your pocket. Then you can go talk to anyone and use real words. And if they really, really, really want to push you, you can pull out the radiative transfer and the tensors and do it to them. But
one thing that strikes me looking at your book, reading it a second time, is both books really, how often you use analogies. You've already used one here. I mean, the switch is an analogy, right? And so tell us a little bit about what you see as the power of analogies, and maybe give us an example of one of your favorite analogies that you've ever come up with that helped you explain a concept.
Well, I haven't any idea what'll be a favorite one, but I think it's
the drunk climate.
The drunk. We'll get through that one. Thank you. He's good. Thank God. I mean, we like narrative at some level, and analogies often feed well into narrative. Your work as a historian of science, a historian of environment, I have found use of history to be hugely, hugely valuable. And I have to admit, I sort of feel nervous having a real historian read this because there's a lot of historical stories in there, but it is such a powerful thing to be able to show people that we have met these problems before and we have solved these problems before. And when we come to energy in the future and so on, there's just these wonderful histories of people doing this before. And it's all history. And so I think drawing on what people know, what they've experienced, how people have gone through it is really useful. So putting people in helps, or animals or whatever. An analogy does this. So with the drunken climate, what we see is that in the history of climate, usually as you force it to change, it changes fairly smoothly. But sometimes the change triggers these sort of wild oscillations. And I hope this never happens outside and downtown, but there are towns in the world where you will observe drunken human beings. And never happened here, no. But if you leave a drunk alone, you leave them alone, they sit there, and if you force them to move, they stagger. And that's sort of the climate. And that analogy has real implications because we're forcing the climate to move. We're hoping it goes smoothly and gradually where it's, you go home and you keep going. But what if it staggers on the way?
And how do you, do these analogies come to you because you're just a naturally curious person who soaks up your surroundings, or do you have an analogy app?
My bicycle. I get the bicycle to work, and I can sit on a bicycle and I can talk to myself, and not too many people think I'm weird because I'm talking to myself. And I say, how would I explain this to someone? What is the way to do this? And so and really hard ones, I live 3 miles from campus, but there's a 5-mile route, and there's an 8-mile route, and there's a 23-mile route. And so the really hard ones are the 23-mile route.
And you've taken, and maybe we can cue up the promo for Richard's Earth, the Operator's Manual TV series. But in addition to writing your earlier book about the ice cores, which does end with, reluctantly, some recommendations on your part, in this book and in the TV show, you really try to wade right into this huge, controversial, important subject. Let's see the promo.
The question video is not available. Interesting. Yes. Okay. Yes. So while they're looking,
okay.
Yes.
Well, one of the
here
things.
It is. Wait a
okay.
minute. This is a different one. This is the third one now.
Americans used to rely on animal power
so
for transportation and to carry goods from place to place, and oil from whales to light our evenings. Today it's gasoline and motor vehicles, and vast amounts of electricity to light our cities and power our economy. But one study claims that Americans spend just 6 minutes a year focusing on energy.
The American public does not like to think about its energy use. The one place Americans do think about energy use is when they're standing at the pump.
Global demand makes oil prices rise and fall in response to events beyond our borders and out of our control.
We worry about how our economy gets buffeted, and the only way...
So that was the third show, and I wasn't in that one quite as much. This is the first one, yeah.
Even the first.
When a big idea down in Louisville gets the funding it needs to finally happen, thousands of hammers start swinging.
Now we get the advertisements. Yes, okay.
22,000 fans take their seats.
Well, economics matters, you know. People have to pay for
New
things.
businesses open.
So we will get there.
Restaurants pack them in.
What are we advertising?
And an undefeatable local economy makes progress.
Goldman Sachs.
Ah, okay. There.
All across the planet, nations and cities are working to reduce their dependence on fossil fuels and promote sustainable energy options.
Because it's the smart thing, because it makes business sense, and it's the right thing.
In China, Europe, and Brazil, energy innovations are changing how we live. And in the U.S., every branch of the military is mobilizing to cut its carbon footprint.
We really believe that the climate is changing.
In this program, we'll share how we know Earth is warming and why, and discover what Earth science tells us about clean, green energy opportunities. I'm Richard Alley. I'm a geologist at Penn State University, but my research has taken me round the planet, from Greenland to Antarctica. I'm fascinated by how our climate has changed dramatically and often. From times with ice everywhere to no ice anywhere on the planet. Records of past climate help us learn how Earth operates. What has happened can happen again. And I know that sometimes things change really fast. I'm a registered Republican, play soccer on Saturdays, and go to church on Sundays. I'm a parent and a professor. I worry about jobs for my students and my daughter's future. I've been a proud member of the UN panel on climate change, and I know the risks. And I've worked for an oil company and know how much we all need energy. And the best science shows we'll be better off if we address the twin stories of climate change and energy, and that the sooner we move forward, the better.
Our use of fossil fuels for energy is pushing us towards a climate unlike any seen in the history of civilization.
So when I saw that the first time, I thought, this is really quite different than scientists used to be, right? You didn't used to have to say that you're a registered Republican, or that you go to church, or that you play soccer. What have you learned about authority and rhetoric as you've tried to address some of these issues, very controversial issues with lots of powerful interests at stake?
Yeah, I think
we as climate science, so I went from being a geologist to being a climate scientist just by wandering through this. And I think initially we believed that we would come out into the public arena and show what we know and people would use it. And that's happened in a huge number of things. You figure out how relativity works and a bunch of other things, and then you build a GPS and people use it. They really like it. And so we figured we'd bring out the information and people would be happy with this, and it didn't work. And I think there's a whole lot of reasons, and some of them we can explore a little because there's some very interesting historical parallels. I suspect that a lot of the reason is that no one who is now making policy learned climate in high school. And so they learned it when they were out in the real world, and a lot of them did learn it from people who were directly and immediately attaching it to policies. And they said, I don't like the policy, therefore I'm going to throw away the science. And all of a sudden this became polarized and toxic. And so what we tried to do, I think intentionally, was to start and say, what do we know with really high confidence? And lay it out. This is what's known, this is what's not known, this is what is solid, this is the best. And then we said, how do you tell the story in a way that allows everyone to come back to the table and say, okay, so you're not telling me what to do, but you are telling me what I can do. Now let's see how we move forward. And so some of these, we had this long discussion about, do you put any of me in it all? Am I just a scientist or am I a person? And we finally decided that so many people make an immediate assumption about what kind of person I am if I say I'm a climate scientist, that it was useful to show that those assumptions might not be right. And then we went to, so you saw a very, very brief window of Rear Admiral David Tetley there. He's a Penn State grad. So this is good. I could sit there as a scientist and say the climate is changing and it will matter to you. But there's a segment of the population that may be more interested to see Rear Admiral David Tetley and his dress whites say that. And it's easy for some people to dismiss me, but those people may have much more difficulty dismissing Rear Admiral Tetley.
I was exactly going to ask you about that because so much of there's multiple episodes, but the first episode, and this is also true in the book, the military plays a huge role. So some of the science itself was originally, as Richard explains, from military trying to understand about missiles. The military then verifies the threats. It becomes part of their defense planning. And then they have all this effort to create alternative technologies that would allow them to reduce their dependence on fossil fuel. And then there's the Rear Admiral. And I thought exactly the same thing. I thought what he says could, if he was a hippie professor, he'd say the same thing. But the dress whites overawes you. But that's not a logical overawing, right? So what's the balance? How did you discuss about how much of this is sharing information and trying to do that in the most honest way, which you write about, and how much of it is pushing buttons, recognizing that people have prejudices or stereotypes, or how did you think about that?
So when it came to the presentation, I had the good fortune to work with really good people. So Jeff Ain Stiles and Erna Akugino did Cosmos with Carl Sagan. And so they're professional communicators and have been doing it for a long time. So a fair chunk of this comes from them. But I really was trying to find what are the paths that will allow me to talk to people that I can't ordinarily talk to, with the starting point that it must be right. So you absolutely start. We're not trying to tell anyone anything that's wrong, but you start with the point of what is right, and then you say, what are the words, what are the openings that will allow me to talk to people who I would not otherwise have the chance to talk to? And there really are people, if you show up and say, Al Gore says, the discussion is over. They will walk out, they will turn you off. There's nowhere you can go with that for whatever reason. And there probably really are people that if you said Rear Admiral Tetley says, they might turn you off. But I think many of them would actually accept the science already, whereas some of the ones that for whatever reason would turn me off or would turn off somebody from one end of the political spectrum will be primed to listen to Rear Admiral Tetley. And I also tend to think that acceptance of the military is broader in the U.S. than acceptance of almost anything else you can think of. And because it really is part of the story. I mean, we knew that CO2 was a greenhouse gas for over 100 years, but getting it right was the Air Force right after World War II. And the Air Force right after World War II was not doing global warming. They really were doing things like heat-seeking missiles. And if you are looking at the hot exhaust up there and trying to shoot it down, if you put your sensor in the wrong wavelength, you will not see it because there's CO2 in the way. And it's just physics. And if it blocks that heat, it also blocks the heat leaving the Earth. And it was simply civilians and military and government and everything else taking that military database and putting it into the climate that ultimately led to this very high confidence that we're going to change things. And so it really is an integral part of the story.
You know, it just occurred to me, I mean, partly because it's an election week, and we have, in national elections, polarized electorate, you know, people joke about all 7 undecided voters. But who would be the swing folks? I mean, there's some people who, no matter what you said, they're not going to believe climate change is happening, or they're not going to believe we're doing anything to cause it. There's obviously other people who are totally sold on the idea, and they're just thinking about what's the best way to deal with it. Who is your target audience when you're trying to change the dynamic?
Right. And I think originally we sort of thought, well, everybody will watch it and it'll all be wonderful. And I think eventually it was more the people who talk to people. So if you have now in high school, you might actually learn a little climate science, but you probably don't learn the history of climate science, and you don't learn the military roots, and you don't learn a lot of the other pieces. So I think now it's more the people that talk to people, to give, if you are interested enough in climate to watch this, you might talk to somebody else, and this will give you the stories that you can use for a wide variety of people that you meet. So my guess is this one is too big to change in one round. It may take a few.
You have a colleague, Michael Mann, who's unfortunately become the target of all kinds of harassing investigations. Did that enter your mind at all as you were making this? That, and he's not the only one, obviously. Climate scientists have become targets. That you were now putting yourself out there. And what did you do? Did you just say, I don't care? Did you try to defend against that in some way?
Those nights I didn't sleep. And I've been on the end. I had somebody that I met for lunch. We chatted about things, a very interested person, and who then tried to get me fired. And he tried to get me fired for something that was completely factually wrong. And at one point I ended up on, my email appeared on one of the wrong blogs. And Christmas Eve and Christmas Day I got sort of 100 emails that were really distressing. And things that people should not be saying in email were coming through an email. So we get it sometimes. And
you might give an example, because most of us, thankfully, have never gotten the kind of emails that you probably have gotten. But what are they? Yeah,
but there are a lot of bad words, and a lot of bad words describing me. And, you know, we're watching you. You know, some of these are not very nice. Evil liar comes through, and that's nice words, but as opposed to bad words. But there's an interesting thing about this, for what it's worth. I've had a few of them that actually identified themselves as being alums of Penn State, and a couple of phone calls or meetings with people on this, and they're pretty unfriendly. And I'll try to send back a really nice answer. And then the ones that identified themselves as alums of Penn State, I actually put in a little note and I said, I don't think that your message was consistent with your alma mater. And there's a line in the alma mater that says, may no act of ours bring shame to one heart that loves thy name. Okay? And what happens next is fascinating. Because what happens next is you get back an email which is sort of, oh my gosh, there's a person on the other end of this. And you're not them, you're you. And then there's an interesting discussion, and I may not change their mind, but that go rotten heck goes away really fast. And I personally think a lot of these are people who actually care very deeply. They probably are not interested in climate science. They're interested in their grandchildren. They're interested in the country. They're interested in other things. And they're mad. And they see something, somebody pushes a button, somebody says, here's the email, send to this guy and tell him he's screwing up. And they do it. And at the point where you go from being them to being somebody who's teaching at your alma mater, all of a sudden it's a completely different dynamic. And so my suspicion is most of this name-calling is from people who actually want the right things and who actually are pretty good people, and if you met them in church, they wouldn't call you names. And that's something which I think is optimistic. I think when the anonymity of the internet goes away, they're approachable.
What else have you learned, either from the filmmakers or from the reactions that you've gotten to the book and the TV show, that's changed how you do try to spread the word?
Yeah, I don't know if this is directly relevant, but I had this remarkable experience that I spent a long weekend in Greenland with 10% of the Senate. So, okay, we went on a Codel, and we got on a military plane over at Andrews, and we went up to Jakobshavn for the long weekend with 10 senators from both sides of the aisle. And when you turn off the camera and you turn off the reporters, they turn into the most interesting people. They are witty. They are telling jokes. They are playing with what you do. They are asking good questions. They are interested in where we're going. It was, and with social skills that, I just sit there and say, how did they get these and why don't I have them? And just truly a fascinating time to interact with them. And when you turn on the cameras, they go right back to script. And you know what they look like. And my suspicion is that all of them at some point have been in an election where something that they said was taken out of context and used against them about 100,000 times. So there are certain statements in the most recent election that if you were in a swing state, you'd turn on the TV and that particular statement was repeated 100 times per half hour. The private sector is doing fine from President Obama, and I love firing people from Governor Romney. You could turn those on, and you'd get 100 of them in a half-hour Jeopardy program. And so nobody is smart enough that they can actually not only answer the reporter's question in a clever and responsive way, but also figure out how their answer could be misused against them. And so when the camera is on, they go to script, something that you've had a long time to work over and try not to make a mistake. So they're playing not to make a mistake, because if you do a million things right and one thing wrong, the one thing wrong will get more airplay than the million things that are right. But with the cameras off, I was really impressed with the senators. And that ultimately, they are those people. And I think that means that if we make a situation in which they believe they can use the science publicly, that they will. I think it's a good thing. I was just truly wonderfully impressed with how good they were.
Do you think the same is true for the climate change advocacy groups, environmental groups, the others, that they have now got a script? People expect them to say certain things. Do you have any advice for things that they might do differently, or do you hear them ever say things that suggest that they have had more interesting thoughts about how to get out of the impasse that we're in?
My suspicion is, and I go over this in the book and we go over it some in the TV show, you can imagine environmental issues that if we don't clean it up, we're in bad shape, and if we clean it up, it costs a lot of money and we don't get anything other than cleaning it up. And if that's the case, some of them we clean up anyway because that's just the way it is. In this particular case, we face this vast issue of how we're going to power people sustainably forever. And the truth is if we deal with the environmental issue, the potential really is there to get a better economy with more power for more people in the world and with more jobs and with greater national security and a cleaner environment. And it just happens that all of the different threads in this case can be woven into something that makes us better off. And there's a few decades of pretty hard work and a lot of thinking and a lot of investing that are not going to be easy, but we have tried. We love energy use. Be perfectly honest, Show of hands, how many of you had to spend the whole summer hoeing corn so you won't starve to death this winter? Okay? We love energy use. We love tractors. Get perfectly honest about this. It is great for us. And we have been trying drill baby drill and blast baby blast and frack baby frack to lower the price enough that we could give the energy use that we have to everybody in the world. Has it worked? We're going to give everybody in the world what we've got at a price that the people in Africa and sub-Saharan Africa can afford what we have. And the answer is probably not. It doesn't seem like we're driving the price of fossil fuels down far enough to give everybody in the world what we've got. The resource is there to do that if we get to renewables. And there's a lot of steps on the way, but the resource is there. We filmed in West Texas, and these West Texas ranchers just love wind power. And they love wind power in part because a wind turbine gives them about $10,000 a year, and if they got 20 of them on the ranch, they're happy with that $200,000. But they also love it because they can reach up in thin air and pull money and power out. And the wind blows everywhere. And if you think about how are the poor people of the world going to get what we have, if we solve this, there's basically no limit on where it goes. Whereas with the fossil fuels, very clearly, we are pulling them out of the ground about 1 million times faster than nature saved them for us. And they are a scarce resource, and scarce resources run out, and it's really, really hard to drive the price way the heck down.
In the book and in the show, a lot of what Richard talks about and writes about is the alternatives, how we could, as he says, have 10 billion smiling people. And I wondered about, neither is a political work, but many of the examples, especially from abroad, that you use, the government played a key role. And I'm wondering if you could just say something about what, if you were to dream, what's the role that you'd like to see government, not necessarily the national government, but governments at all levels, play in helping achieve the possibilities that you see?
Yeah. So the first time I knew what a GPS was my advisor, Ian Willens, was surveying motion of ice streams in West Antarctica. And they used to survey motions by things like theodolite surveys from the coast. Horrible, horrible things. And they'd get elevations by, you'd have 3 snowmobiles, and you park 2 of them with their pressure altimeters, and then you drive the 3rd one, and the pressure is changing because the weather's changing, and it's also changing because you're changing elevation. And you can track the weather with the 2 that aren't moving, and then the one stops, and then another one moves, and then another one moves. And it was hideous. And with the GPS, you could just go in and here's where I am, except you had to come home and reprocess it because it was a government secret where you were, because the GPS was an Air Force project, and they were dithering the signal, so you couldn't exactly find out where you were because they were afraid somebody else would seal that for their military. And the receiver cost $10,000, right? And you've got one in your cell phone, and it's not dithered, and it's better than what we had then. It was very clearly that GPS came from the government. And then once the foundation was there, then private industry made it really dirt cheap, so you got one on your cell phone that works. The first time I logged on the internet, I was up at Wisconsin, and it was the ARPANET, the Defense Advanced Research Projects Administration. The Defense Department said, we want our researchers to talk to each other, let's build the internet. And that's in your cell phone too. And so these sorts of things, if we historically, you're the historian, you should tell me this, but my impression is that when we look back at the history, that the big decisions always had us together deciding as well as individuals or individual companies deciding, that there was always some element of us as a community, and however exactly through whatever government that was done, there were decisions that were made. The government said, we will buy Louisiana, and then we will give it to homesteaders. This was that was
pretty good deal.
It really was. And you probably remember the name of the act, but when Eisenhower built the interstates, there's
right.
National Security and Defense.
The Interstate Highway and National Defense Act. Yeah.
National Defense Act. And it's because Eisenhower tried to drive across the country with a convoy back around World War I, and he almost didn't make it. And he said, how can we be secure if we can't move material across the dead blame country? We need some roads. And so that is our history. And then you say, okay, so and the truth is, I've got colleagues who up at Penn State had government funding to work on natural gas. And where is it and how do you get it out? And you'll find a column from Terry Engelder pointing out that in fact fracking was generated by federal research. Okay, and most of the federal research actually has been going not to wind and sun; it's been going to fission, fusion, and fossil fuels in some order. But most of our energy research has not been going to renewables. And so you say, fine, those were the things. Fossil fuels got us where we are. But the long-term future has to be something else because we're using them 1,000,000 times faster than nature saved them. And we always in the past have gotten together and said, let's find that long-term future and let's lay the groundwork so we can get there.
Let me ask just one more question before turning it over. I'm sure we've got lots of great questions, maybe some about Delaware, maybe some about other policy implications. But you had a chance, and you should watch the film. It's beautiful as well as inspiring, to go all kinds of places, talk to lots of people. You're optimistic, you're upbeat. What was the most inspiring thing that you learned in the process of working on the book and the film?
Yeah, boy, pulling it down to one thing is so hard because there were so many good stories out there, and it really is that so many people do want to do the right thing. So many people really do want their grandkids to have a good life. So many people really are worried that right now the people changing climate are not suffering very much, and the people suffering are not changing climate very much. There's a big, we benefit from the fossil fuel use, and the losers are poor people in hot places and people who haven't been born yet. And there's a lot of people concerned about that. And the dominant rhetoric that you hear bouncing through the press just doesn't seem that representative of what's going on in the real world. And I think ultimately that that's the optimistic thing, is there's a lot of really good, really bright people out there.
The questions, I guess we're going to have on each side of the auditorium a mic, and the floor is open for good, bright, inspiring people, or, I don't know, nasty, churlish, to ask questions. We'll start right there.
Yeah, I wonder what you can say about what we could do to get climate science into the schools, the public schools, elementary schools. I mean, I think children, even at a very young age, can start understanding important things like not leaving lights on when you're in the room, when you're outside the room, or not leaving the door in the wintertime. But as time goes on, they really ought to learn why we have seasons and why it's, you know, warmer in the summer and colder in the winter, and some basic science, so they can begin to understand how the world works in an important way. And right now, as you know, we're very, very scientifically illiterate. I remember seeing a film of Harvard graduates, and these were all in their caps and gowns and so on, and they were asked, why is it colder in the winter than the summer? And they say, well, isn't that because the sun is farther away from the earth in the wintertime? Of course, it's the other way around, really.
Yeah.
They had no idea of the tilt of the axis and the role of that. So, you know, this illiteracy and this ignorance is very concerning to me. So I wonder, you know, the problem we're going to run into, of course, is we're going to have people that insist on equal time for creationism if you're going to teach modern biology, or equal time for climate denial if we're going to teach climate science.
Yeah, I know. This is hard, and I actually have a talk I do that is if you wanted to cause real trouble for a school board by telling them why they shouldn't teach gravity. And I'll tell you the truth, if you gave me 10 minutes, I could convince you that gravity's a really stupid thing to teach in school. It's really easy to do this sort of stuff. And you're certainly right, this is a huge challenge, and I don't have a glib answer. More and more is being driven by standards, because the teachers are more and more being forced to teach to the test. And as long as that exists, making sure that the standards say something about this field is one way forward. A lot of it is happening. I think if you ask the university faculty who are here and some of the students, you'd find that many of them are now starting to do outreach in the schools. They're starting to and I think that you'll find that the university is recognizing that this is a valuable thing, even if no one is paying them for it. So I think you'll start to see things bubbling up around you in a lot of places. I'll also, I almost hate to say this, but if the students were to come out of elementary and especially middle school and not be scared of math and still be interested in communicating and writing and not be turned off to science, I think we'd still be okay, because I think we can teach them the science later as long as they come out saying, wow, science is pretty cool, and I'm not scared of math, and I'm not scared of English. And so in some level, you know, if we can't teach science in elementary school, tell them to go outside and see if they can find something eating something. And we'll build on that later, okay? If you can get that far for me, I'll get them when they get to college. So the thing that really terrifies me is that we've got a fair number of people that don't like communicating terribly well, and we've got a lot of people who are almost proud of the fact that they don't do math. And I think long-term, so many of the jobs now are going to require, you can't be scared of math if you're going to be in business, if you're going to be in economics, if you're going to be in engineering, if you guys, a lot of these high-paying jobs, you can't drop out of math in 4th grade and expect to make it. If we could put every dad blames school in America, if there's a big sign on the wall that says math is money, we'll get there, okay?
My turn. And then there was Sandy. I think while this event is fresh on our minds, I would like maybe something more scientific from you in a perspective. So we had a Frankenstorm, and Hollywood spun up the day after tomorrow, and there were monster storms flooding Manhattan, and that happened. And Irene went up and flooded New England, and one of those other tropical storms. So something's happening, and the Arctic is thawing. Is there a switch that has popped, and we have a wake-up call?
Yeah. I don't think we've switched yet, but I'm worried about the switches, especially in West Antarctica and sea level. But it's clear, I mean, we've had big storms before. We'll have big storms without any help from us, but there was more warmth in the ocean because we helped it, and the warmth powers that. And there's more moisture in the air because of the warmth in the ocean, and that makes it a little worse. And the ocean has come up about that far because it's getting warmer, and most of that is us. And so it's very clear that we push this thing. And I think people are starting to get that, and I think it really does offer the teaching moment for a number of things. One of them is that even if there's no switch in the climate, there's a switch in human things. Either the water stays just below the hole that goes into the subway, or it goes just above the hole that goes into the subway. And the difference is the same in Katrina. We almost got by without going over the top of the levee. And so you see these switches in human systems and say, wow, we need engineers to think about those because they really matter. We also see the costs rise faster than the ocean, the costs rise faster than the temperature. If it stays just below the lip, man, it's pretty cheap. If it goes just above the lip, now we're in big trouble. And so you can start to see this business that waiting has costs because we're going to get bigger changes, we're going to get more sea level rise and other things. But because the costs go up faster than the temperature, whenever we decide to do things, it will be helpful. And maybe that's the biggest picture. Waiting has costs, but no matter when you start, it still helps because the costs keep going up faster than the temperature does.
The temptation is, since this is a global problem, that we'll just try to engineer ourselves out of the situation, and maybe that's inevitable as well.
Yeah. So what he's referring to, those of you who I would guess you're talking about stratospheric aerosols or other sun-blocking things. So if it gets too hot, and we really, really, really need to cool it off, it is fairly clear that there are engineering solutions. When a big volcano erupts, it puts sulfur dioxide in the stratosphere, it makes sulfuric acid, it makes little particles, the particles block the sun, and we get a little cooling for a couple of years. The amount of stuff needed to make a difference is, you can think of putting it up there for billions of dollars a year, not trillions. And so in principle, we could do it. There'd be some ozone worries. There are some worries that it's not just anti-CO2. It would tend to dry out a lot of places because it reduces the direct sunshine on the ocean that causes evaporation. It does not stop ocean acidification. So it's not... Most people that I know don't really think it is a highly good thing that we'd want to do immediately. But in the worst case, if you want to scare yourself, if somebody gets locked in a sauna, they can die. If the dew point is above your body temperature, you make heat, you can't get rid of it, the heat accumulates in you, and eventually you die. In the worst future that you can envision, we could make a lot of the world that hot. That sort of burn it all in fairly high climate sensitivity, and that's not this century. But in the worst futures that you can envision, you can imagine a world in which we made it hot enough that people really did have huge trouble living without an air conditioner at all times. I think it's really wise to have a few atmospheric scientists looking at geoengineering just in case.
Hi, I think we're really lucky in Delaware now for a couple of reasons. That we are involved in the next generation science standards, which are going to include climate change. We also have a new Secretary of the Department of Education that has decided that Delaware by 2014 will be first in science in the nation. And as we look at these next generation science standards coming on board, where should we be going as educators to look for the topics that are most important to work with the children that we will be teaching?
Yeah, that's a real, I mean, if you've got the science, the standards, so you know what you have to cover, my first thought is you do whatever really excites you as an educator. And I'm not answering your question, but there's this long history of educational innovation, which is virtually all educational innovations initially work because there's somebody that cares about it, and they care deeply and passionately, and they're going to do it. And then almost all educational initiatives fail because at some point they take what you've done that's so exciting and they say to everybody else, do this. And we're not going to help you do it, and you're going to have to put in extra work on the side, and you're not going to get any reward for that, but just do this. And so all these wonderful things go thud. So if you care about something, use that, and whatever it is, it's going to work because you care about it. That's not still a good answer. But if you have to go with the standards and you get the standards there, that gives you the basic topics. And then, get the information from the national academies, and they are making things more and more available. And are you and I'm sorry, could you tell me what level of educator you are?
I work for the Delaware Nature Society, so we're doing pre-K through college education.
Wow, okay.
I really liked your statement about just go outside and look.
Okay, all of the above. But what you also do is, if you don't have what you need, there are 20 people in this room who probably do. And there are also 20 more who have what you do and are students and are really excited. And so my guess is that this university is going to reward some people for getting out and working with the public. You want to make a little bit of a pest of yourself. And at the point where they get you to these people sitting down front here on the left, you're going to get there. Look at them. You turn around and take a look, because this is what it is. There's undergrads, there's grad students who actually are interested in helping people, and they'd come out for the afternoon, and they would help you find what it is you need. And we're going to need more networking.
Thank you.
Do any of our students have questions?
And you're ready to volunteer. I know you got a midterm, but then you can volunteer.
That's my student.
Okay.
Well, you mentioned that a lot of the people that are likely to suffer the effects of climate change first are those that are not necessarily creating the problems, and I was wondering if there was any responsibility of the nations that are responsible to kind of protect those other countries, and what does that entail if it does?
Yeah. Big questions, and I try very hard not to be policy prescriptive, so I'm not going to tell you what to do. I mean, the back thing I said up there, I go to church on Sunday, and I actually did make it to church on last Sunday. Often I'm traveling, but those of us that go to church on Sunday, and many who don't, the golden rule is not just about us kidding along. It's a little more serious than that. And so, personally, this bothers me rather deeply that my lifestyle is hurting somebody else and not me. The broadest possible picture, right? We as humans, if we live, are going to have impacts on the environment around us. And this has always been the case. I've worked with Todd Soers and John Mischler, who was a grad student with Todd, on the history of the isotopic composition of methane in the atmosphere. And methane from fires has a different isotopic composition than methane from swamps. And in the 1500s, there's a drop in methane, and that drop in methane comes almost entirely from a drop in fires. And we're pretty sure we know what it is, which is that when European settlers got to these shores and their diseases depopulated the Americas, the native people here had been burning a huge amount to manage their environment, and they were burning enough that they really were changing the composition of the atmosphere. And when they died, they quit burning, and the atmosphere changed. And so changing the atmosphere is not unique to us as modern humans. There is some argument that per person, our impact on the world has actually been dropping. It's just that our population has been growing faster than the impact has dropped. The megafaunal extinctions, the mammoths and what have you, fairly clearly there's a human fingerprint in this as well as a climate change fingerprint. So we've always impacted the environment, we always will, but right now, there's more of us on the planet living better than we ever have. And so what you can do is say, I as a person am causing damage. I am. I as a person have the opportunity through learning and teaching and sharing and building to help others. And so far, the helping has beat the hurting because there's more of us doing better. And the question is, are we doing more helping than hurting? Am I? Are you doing? And you're going to. But that's really the question to ask: is can we get to the point where we do more helping than hurting? Because we can't possibly remove ourselves from all impact on the environment. It just can't be done. And this has always been true of humanity, and it will always be true of humanity. And the question is, do we learn enough? Do we teach enough? Do we share enough? Do we build enough to make up for that? And so far, we have, as a species. You're the historian, is that fair?
Yeah.
Okay.
I mean, this is really a follow-up on that question before. So if I push this harder, should we help, for example, Bangladesh being impacted by sea level rise, to burn more fossil fuels, to use more energies, to develop economically better, to protect themselves from sea level rise? Is it possible that that might be a more cost-efficient way of doing it than trying to stop sea level rise? It's a loaded question.
Right. No, this is a very loaded question, and it's the right question. So in the short term, the general rule is that the more money you have, the less the more resources, the more abilities, the more power you have, the less susceptible you are to climate change. And money is what the economists use to measure that. But if you are well off, you're not immediately suffering, and if you're poor, you're immediately suffering. And so you could say we should stop climate change to stop the suffering, or you could say we should make them wealthy to stop the suffering. A fair chunk of our political discussion is stop wealth, stop wealth, stop. You know, to an economist, and any of you who are economists or any of you who have taken economics, the moment you can say, here's the two end members, you can virtually guarantee that the economically optimal answer is somewhere in between. Right? And what that does is, by a purely economic, optimizing the marginal good of consumption or whatever term you're going to use, by a purely hard-nosed business economics, the world can grow its economy 4% per year forever, you still do something to slow down climate change as well as doing things to help people by investment in the economy. And once you move off of the my end and nothing else, then it's an interesting discussion. And then you can say, okay, but what about national security? You do a little more. What about employment? It looks like there's more jobs in the alternatives to fossil fuels. What about a cleaner environment? Well, you do a little more. What about the golden rule? Maybe you do a little more. But where you put, you know, the sort of, we must stop burning fossil fuels instantly now, is not seriously on the table. It's a really long walk for me home. You know, and so we're going to burn some. But we do have some people who are arguing for do nothing about climate change. But a hard-nosed economic optimization says you do something about climate change. And once you move that needle, now it's an interesting discussion. We can bring in scholarship. We can make wise decisions. And so I think that the sort of Nordhaus 4% discount rate analysis version is extremely powerful because even that says you do something about climate change.
It seems to me that we can't not do something. I mean, we, as you say, everything we do influences things. We're now one of the dominant things on this planet, right? You suggest that maybe we should be thinking about trying to freeze our climate where it is now, but that's a choice, right? I mean, if we're really not to have any impact on the climate, we'd all be in an ice age in another 5,000 years. That's probably not what people have in mind. So how do we choose what climate we want to be?
Right. I have no idea. The natural trend, by the way, we used to be worried that we were dropping into an ice age, but we'll probably have 20 or 40,000 years before the next one naturally. So there's actually people who slightly tongue-in-cheek say that, yeah, but there's people who actually slightly tongue-in-cheek have said that maybe we should just save the fossil fuels and burn them in 40,000 years when we need them to head off the ice age. Okay. The truth is we probably already have headed that one off because we've burned enough fossil fuels to stop it. But you raise a really big question, which is ultimately we are choosing what the Earth's climate will be. And either we will do that of volition or we will do that by stumbling merrily into the future and not doing so. And I don't have a prescription for this, but what we do see is that the costs go up faster than the temperature. And so what that would do is say that things that slow down the warming until we can get our act together are probably wise. And so in that sense, at this point, you're asking the long question, which is once we get together, we understand what we're doing, we have the capability, and we're going to decide what climate we want, where do we put it? Right now, it's more, can we slow down the damages until we get that ability? And so it's a much easier answer at this point. And you're asking the next one, which is hard. I don't know. What do you say, Adam? What would you tell him?
I would use a trick from a friend of mine. Next question.
It's a really good question, and it's a discussion we have to have, but really it's a discussion that they have to have because you and I have too much gray in our beards at this point. Because that decision will not be made. We don't have that capability at this point. A serious transition of the energy system is 30 years. And it might be 40, but no way you're going to do it in 10 or 20. And so realistically, the decision of we are making this transition, where are we going to point it at, where does it stop, really will be their decision and not ours.
So I just read that there's 2 or 3 shipping terminals proposed, I think for Washington State, the Northwest, to ship coal from the Rocky Mountains over to China. So China can burn more of our dirty coal. Oh, sorry, I used that word, dirty. But I live on the West Coast. You know, we get soot particles from China already. There's a smog layer across the country that I see when I fly back and forth from time to time that wasn't there some years ago. And then I also read that China has like $3 trillion sitting around that they need to find out what to do with their excess, from their trade and so forth, that they've been so prosperous. So my question is there a way that we somehow can encourage, and maybe it's happening already to some extent, but to work with them, with that excess capital, to really move this ahead instead of encouraging more use of fossil fuels, that will only be detrimental to the whole world.
Yeah. And it's easy to get depressed, It really is. It's certainly there are, trade agreements, there are technological innovations, there's a huge number of things that one can do. And you could get, probably several people in this room would give you a good list. One that often comes up really high is simply putting a price on changing the climate. So when you start talking the biggest picture, it's virtually certain that you need a lot of innovation. You need a lot of bright people thinking about it. You need invention. You need maybe a little bit of stimulating this to get it going. But right now, there is this subsidy for fossil fuels, and that the climate change is not part of the cost of your ton of coal. The estimates that I've seen, in central Pennsylvania, we are largely coal-powered for our electric. And there's a wide range of estimates, and you can get a lot of people get fairly hot under the collar about this. But the estimates tend to be that if I spend $1 on electricity, I have caused society to spend $1. Because society has to put up with the particles and the acid rain and the uranium and the mercury and the acid mine drainage and the mountaintop removal and the climate change and all those other impacts. And that it's sort of the same price. And like I say, a lot of people will argue, it's interesting, I've seen 3 times, I've seen less than that, but sort of half, my electricity is half what it costs society. And so people start saying, well, we could outlaw it. We could just say, no, we won't do that. But no one's really proposing that. What they're proposing is, why don't we just get rid of the subsidy by putting an extra cost on that electricity? And if that were done, then wind and sun look a whole lot cheaper. And so this sort of thing of using a price on carbon to do it, we were chatting at dinner, and I did this piece, and I apologize for being long-winded, but this may be useful. We tax tobacco, and we tax tobacco to raise money for the government and to reduce smoking. And we tax alcohol to raise money for the government and to reduce drinking. And we tax your wages to raise money for the government and to reduce working. If I offer a student $10 to come help me, they might come help me. I offer them $5 and the government $5, and they say, come on, why should I bother? And so at some point, back when there was talk in the Senate about a cap-and-trade bill, Waxman-Markey, they asked the EPA Environmental Economics Group to run up the economic impacts of this. And they did a whole bunch of different possibilities, and one of them they called Scenario 16 was you put a price on carbon, and you use that to reduce the tax on wages, dollar for dollar. And under that, the economy grows faster than what we're doing now. You reduce use of fossil fuels, but by taxing something we don't want, climate change, instead of something we do want, people having jobs and getting paid for it, you actually end up growing the economy faster. And you can start thinking about a world where people talk to each other around the globe and say, okay, here's the deal. We're not going to outlaw your energy system, but we're taxing ours, and they're taxing theirs, and they're taxing theirs, and you can have 2 choices. You tax yours, use it for whatever you want. Or we'll tax everything that goes into and out of your country for that much. And that might actually be hard to do right now internationally, but it raises an interesting thing. Suppose we did cut an agreement with Europe and China and a few other countries that said we won't outlaw it, All we're going to do is make sure that if you don't subsidize it, and you get to keep the money. It's worth a thought. And people look at how difficult it would be to get international agreements with all the things on the line, but that one might be a little more straightforward. So, like I said, a lot of smart people have thought about lots of ways to do this, and how do you cut it internationally. And to be perfectly honest, you're a little bit past my expertise at this point. But there are several smart people have looked at this one, and like I say, and people on both sides of the aisle are saying, you know, a carbon tax instead of a wage tax, a carbon tax instead of taxing you owning property, you know, a carbon tax instead of taxing things that we want might actually be a good thing, and that might work for a lot of people in a lot of the world.
Hi. Excuse me. I just want to thank you for being so optimistic in such a non-optimistic scenario. And that's why I enjoyed seeing you when you came the first time. Barring any switch from Congress, which, you know, seems unlikely, maybe soon, or hopefully in my lifetime there'll be a switch that, you know, has a tax or something like that. Have there been any natural mechanisms or natural switches that you've seen in those short time frames that you can tell that the climate reacted in a way to stabilize itself? Maybe like the storms, we think, do some of that, but are there any other, or can you maybe explain what happened after those switches in the past?
Yeah. So the climate certainly will stabilize itself at some level. Right now, we're fairly fortunate that of this CO2 we put in the air, close to half of it is going into the ocean. That's acidifying it, but it keeps the rise in the atmosphere down. Eventually, that neutralizes itself in part by dissolving shells in the seafloor. The last time nature made a really big release of CO2, we actually, if you drill a sediment core through the record of that, it's the Pliocene-Eocene thermal maximum, but if you drill a sediment core through the record of that, the sediment core is sort of white, brown, white. Well, why? Because there's white carbonate shells, except in the layer that was at the seafloor when that happened, and the CO2 dissolved the shells, and that neutralized it. And so eventually nature will undo this. But most of the big stabilizers are pretty slow. So if we put most of the fossil fuel in the air as CO2 and let nature take care of it, you're looking at thousands, tens of thousands, 100,000 years to get it back down. Sort of 500,000 years is the residence time of carbon in the ocean atmosphere system, and so that would ultimately be the time to do it. If there's fossil fuel formation, it's a little faster. So realistically, we're going to see a lot of warming if we burn a lot of it, and nature has real troubles on doing that. There are, you know, we're studying really hard in West Antarctica now, and just absolutely fascinating things. And there's some chance that West Antarctica will hang on and it won't dump its ice into the ocean. It is very clear that there are a number of stabilizers that try to keep it where it is. It is putting sediment down, and that tends to build a wall between it and the ocean, and that's a good thing. It keeps it there. And some other things like that, there's some chance that we'll kick it off of its stabilizers, and then it will go fairly fast. So there certainly are things. When we first found out about these abrupt climate changes, ultimately they came, the ones in the north, the ones in the Greenland ice core, ultimately today, if you go off of Norway in the ocean in the winter, the ocean is not frozen. And if you go at the same latitude elsewhere around the north, the ocean is frozen in the winter. And the difference between frozen and not frozen off of Norway is pretty big, 40 degrees or something like that. And if as we came out of the Ice Age, the meltwater from the ice sheets freshened the ocean, and when it's fresher, it's easier to freeze, and so it froze sometimes. And those big switches were whether the water off of Norway froze or sank in the winter, basically. And when it froze, it got really cold in Europe, but it also got really dry in the northern tropics and in some of the monsoon belt. And that's really what scared us. That drop in methane that went with cold in Greenland was no rain in places where billions of people live. And we were really scared that because we're melting Greenland, we're putting fresh water in the North Atlantic, that would favor winter freezing even if it's getting hot in the summer. And that made that silly movie, The Day After Tomorrow. But at any rate, and that one now we're fairly confident that we won't melt Greenland fast enough to make the North Atlantic fresh enough to allow it to freeze in the winter until it gets so hot that it's not going to freeze in the winter anyway. So we're fairly confident that we don't wipe out the rain in the northern tropics by that mechanism. So this is a good thing. So it's not all bad news.
One last question.
Would you be able to speak a little bit about your thoughts on what it would take to shift military focus from what it is now to renewable energy and sustainable use of water or natural resources?
Yeah, military focus. The military's trying a lot of things, and we actually have film in the TV show. A huge number of the casualties in Iraq and Afghanistan were fuel convoys, or fuel and water, but mostly fuel. And a Marine base knows how to protect itself, and they're really good at that. But if you have to drive this long supply line across a whole country in which some of the people don't like you, it's a very hard thing to avoid somebody getting something to blow up near your supply line. And so at some point the Marines said, gasoline that is not burned, diesel that is not burned is lives saved. And so they got really serious about conserving energy and about generating energy at the bases. And you put a sunshade over the tent with solar cells on it, and you can run your GPS and your night vision goggles and what have you off of the sun during the day and some batteries. And these fuel trucks stay home and people live rather than die. And there's a lot of things in the military that they're very interested in doing that. There are people in Congress who have been trying to push them to do less of that. But the military has said, we think that cutting energy use, finding alternatives, is ultimately a national security issue, and that this is something we need to do. It's also at least raises that interesting issue that if they found beyond any shadow of a doubt that a long supply line that was really important was a vulnerability, is there any relation between that and the way we supply the country? And there's a whole lot of people would look at that and say, we've got a lot of supply coming in a very long line in ships from very far away, and that would be something that could be cut off fairly easily.
Maybe one more, if you'll end on a high note. Down in front.
I have a very simple question. Thank you. Richard, I have a very simple question because you are a geologist and had studied physics before, physics before. So major concern for the rising of sea level for people who live in New York City is the rising of sea level, temperature aside, right? So there was some theory out there that I never got a straight answer from climate scientists. The melting of glaciers on Greenland is going to raise sea level because the ice turns into water. But for Antarctic and Antarctic, if it's floating ice on the ocean and that piece of ice melts, the volume of the water stays the same, right? The sea level does not rise. So that is coming.
Right.
I don't know, probably 90% of the ice on Arctic and Antarctic is floating. If they all melt, the sea level is largely going to stay the same.
Yeah. Okay. So sea level. Broad picture on sea level. If you warm the, what are the numbers? It's close to 1 meter of sea level rise per degree of warming, just because the water expands. And it's 0.7, but it depends a little bit on whether you put the heat into the cold or the warm water. But at any rate, as we warm the ocean, it expands and it rises a little bit. Mountain glaciers, the Alps and the Rockies, and we were talking about the glaciers of Glacier tonight, and they're about all gone. If you melt all the mountain glaciers, you raise sea level about that much, and then the mountain glaciers are gone. We're pumping a little water out of the ground, and it goes down the river and into the ocean, and so we're depleting groundwater to water crops, but probably not more than about that much. And then the big deal is the big ice sheets. And Greenland is 7.3 meters. It's 23 feet of sea level, globally averaged. And 23 feet would be big. And Antarctica is a lot more than that, not quite 10 times more than that. Greenland, pretty clearly, if it gets too hot, it melts. Initially, there's some flow and iceberg production, but eventually it pulls out of the deep fjords, and then it's just a big ice cube sitting on land, and the air melts it, but it's probably centuries or longer to do that. Antarctica is much more interesting, okay? So we used to get these emails or mailings from these people who were really scared because they had discovered that it snows in Greenland and Antarctica. And it snows and it snows and it snows and it builds up, and then the world's going to roll over. Okay, and what they forgot is that the pile spreads under its own weight. And so all big piles spread under their own weight unless they're really strong. This building is strong enough, its walls are not bulging out. But you remember the old Gothic cathedrals, the walls bulged out and the roof caved in until they built flying buttresses. If we had a glass of water here and I poured it on the floor, it would make a very wide, shallow pile. If I poured pancake batter on there, it would make a thicker pile. Ice is a pile, and it's spreading very slowly under its own weight. Okay, now when it spreads, the snow piles up on top, it spreads down to the edge, it melts on the edges, or else it breaks off to make icebergs. When it spreads down to the sea in Antarctica, it doesn't immediately make an iceberg. It flows over the ocean, but attached to the land still. And as it does so, it's almost always sitting in a bay. So the ice is moving up here, but there's friction on the sides of the ice with the rocks because it's in a bay. And that friction holds back the spreading. Those ice shelves are the flying buttresses of the ice sheet. You warm the ocean, it melts them from the bottom. That reduces the friction on the side because they're thinner. That lets the pile spread faster. And so the worry is warming ocean, melting floating ice does not raise sea level, but it thins the sides that are rubbing against the rocky walls of the bay or the fjord, which reduces the friction that lets the pile spread faster, and that raises sea level. And that's really where our research is now. We're doing a huge amount of work on this one, just fascinating work. But 1 degree warming of the atmosphere in Greenland melts the ice on top by about 1 meter a year in the places that are melting. 1 degree warming in the ocean melts about 10 meters a year on the bottom. And so the ocean has a bigger lever because heat transfers better in the water. And so ultimately, warmer ocean is melting ice shelves, is less friction, is faster spreading pile, is sea level rise. And right now, whether that one's going to bite us in the butt or not, we're not sure. But that's what we're working on. So it really is. And I have gotten Dr. Alley, you should know that floating ice, when it melts, doesn't raise sea level. Yes, that's true. But it does reduce the friction and lets the pile spread faster. So this is something, and there's a little physics in this one, and there's some remote sensing, and there's some geography, and it's worth thinking about for grad school because the ice sheets are a big deal. And and like I say, it's scary to learn these things, but it's so much fun to see how the ice works, to read the history of the ice in the ice and in the sediments underneath. It's physics, it's chemistry, it's hydrology, it's remote sensing, it's geography, it's GPSs. It's just truly a fascinating thing because it all comes into these ice sheets. So yeah. I'm not sure if that was the right one to end on, but
Well, thank you so much for being a model of helping more than hurting.
Thank you.
Thank you
all.
all.
Thank you.
Have a wonderful evening.
Oh, this is
That was great.
outstanding. Wow.